In this demo, we look into the workflow and benefits of using AI-enabled development and optimization of the test library for assessing the quality of financial transaction processing systems. Our method relies on the model-based testing approach and is facilitated by the use of Exactpro's proprietary AI algorithms. The approach can be used to optimize an existing test library or build a new test library with the optimization logic embedded into it from the start. Compared to a traditional test library, developing or optimizing a test library using AI-enabled model-based testing introduces the following business benefits. Optimizing the human involvement required for the creation of unique test scenarios. Reducing the hardware footprint and time to market by limiting the number of data points to be covered in testing to a reasonably low level. It also helps our clients increase their return on investment by boosting the effectiveness of the test library. AI-enabled test script generation and optimization is part of Exactpro's AI testing approach that also involves intelligent test execution and support in test results interpretation. Let's look into the AI-enabled test generation and optimization in more detail. We will start by establishing some basic terms. Model-based testing is a software testing technique in which the runtime behavior of the software under test is checked against predictions derived from a model. In a general sense, all software testing is model-based. In a narrow sense, we use the term MBT to describe the testing based on well-structured models. A model is a machine-readable description of the behavior of the system under test expressed as input sequences, actions, conditions, outputs, and flow of data from input to output. The model serves as the basis for test coverage point discovery. A test script is a sequence of instructions created for the execution of a test, expressed in machine-readable form. The purpose of test scripts is to cover the target coverage points obtained from the model. For traceability purposes, each test script is attributed a unique name. A source test script is a test script used by Exactpro's proprietary generative model to replicate the logic of a template test scenario using relevant data permutations. A source test script is universal enough to incorporate many types of system-specific variables. Modification is the process of the generative model creating multiple permutations of the source test script based on available conditions. Modifying a test script can take two forms. The first one is iterating through an existing test script using sets of enumerated values that the test script is reading from an external file. The second way is building on top of an existing script or otherwise changing its structure. Last but not least, a coverage point. It's an annotated part of code, message, sequence of messages, or a state in the model or a system under test that characterizes system behavior. Let's see AI-enabled test script generation and optimization in action. We'll look into test script generation first, using an exchange system as an example. A test script consists of lines of code that include variable parameters such as types of clients, order types, time in force, price ticks, financial instruments, and others. The parameters will be iterated through in a nested loop based on the pool of relevant data. Depending on project specifics, the algorithms may be set to choose the values at random or iterate through the entire pool of parameters previously derived from the model and placed in external files. Some lines of code can also be eliminated and new ones added, adding extra features to the test script if required. Each individual test script will represent a single value of each specific parameter. During the modification step, each test script gets annotated with a set of tags that collectively attribute a unique footprint of coverage point labels to its code lines. As a result of the generative process of creating and executing test script permutations, we receive a test coverage report on each test script. We also receive an aggregate HTML report for the overall volume of test scripts executed and code lines covered or omitted by them for various reasons. For example, some positive scenarios will naturally skip some of the branches of the code. By looking at the aggregate report, we can see how well each test script covers the system's functionality and what is the current code coverage of the test library. Let's now move on to test script optimization, where a set of algorithms will be launched to assess and increase the effectiveness of the current test coverage. Let's say we have 50 financial instruments and 80 users. That alone lets us produce 4,000 possible test script combinations. With the introduction of more variables, the growth of test coverage points becomes exponential. The coverage points approach allows us to see that while each individual test script or test script part bears its unique footprint, it may be far from unique in terms of its test coverage value. The aim of Exactpro's AI testing approach is to create the most efficient version of the test library, the one that features a minimal number of tests corresponding to the highest possible number of code coverage points. For visualization purposes, let's look at a simplified matrix. The turquoise cells stand for the test library elements covered by the current iteration of the test scripts, and the white ones stand for the elements that have not been hit or analyzed by the current test scripts. Based on their coverage points value, all test script modifications are assessed by the model. The model then detects identical lines of coverage points along the horizontal axis. They are then sorted and the replicates deleted from the list of coverage points to be analyzed from now onwards. We've now reduced the number of coverage points to be checked by test scripts, while preserving the level of test coverage of the system's functionality. Next, we can further optimize our test script subset along the vertical axis by getting rid of the test scripts with little value and only keeping the ones providing the widest test coverage. The level of optimization the model can deliver widely depends on the system complexity and the size of the existing test library. An example of the improvements we've received from a real-life implementation of the model is featured on the screen. We've significantly reduced the number of test cases and coverage points to be checked, while keeping or extending the level of test coverage. After the optimization, we can further enhance the test scripts and improve the quality of the test library using AI algorithms. Let's now address the most pressing questions that come to mind. Why are we not using the entire volume of variables for model training? First of all, the entire volume of data is infinite. We will not be able to cover all permutations anyway. Our goal is to select a subset that's optimized for defect discovery and description. Even the most scalable systems have limits on the number of transactions that we can explore in a limited amount of time. Most often, test environments are not that strong, and in some markets, such as those involving DLT or other slow technology, we have to be even pickier in selecting possible actions. Can the approach be used on new or existing test libraries? The answer is both. Existing test libraries can benefit from optimization and can be enriched with new meaningful data points. This will increase the complexity and quality of the test coverage. New libraries, on the other hand, can be created from scratch using our data-driven AI testing approach with the optimization logic embedded into the test library generation algorithm. With the main analytical power siloed away from the code, this approach is applicable to a wide variety of business domains and use cases. Models can be reused to test and build systems with similar functionality. Software testing based on early-stage AI-enabled system modeling provides a fundamentally different scale of system exploration, quality, test coverage, and automation for numerous business cases, strengthening the operational resiliency of complex, high-load, high-availability systems in finance and well beyond. Visit us at exactpro.com to learn more and set up a discussion on how our AI testing approach can help you introduce greater efficiencies in your software delivery.